It is an icon of speed.
We flew twice the speed of sound.
Faster than a bullet from a gun.
It was Concorde, however, that displayed the glamour of high-speed flight, and the plane was supposed to revolutionize the commercial aviation industry.
Imagine cutting a transatlantic flight from 7 hours down to 3. Picture boarding a jet in New York and stepping out in London before lunch. For decades, this was reality. The Concorde made supersonic travel an exclusive but very real experience until 2003, when the last flight landed and an entire era came to an end.
A fatal crash in 2000 put an end to the program. It was 2003 when the Concorde last flew passengers over the Atlantic at twice the speed of sound.
But now, after more than 20 years of silence in the supersonic world, the dream is coming back.
Supersonic jets could be making a comeback nearly 20 years after the Concorde stopped flying.
The company Boom Supersonic has released a demonstrator aircraft. It's a model of a future airliner the company hopes to roll out in 2026.
New aircraft are flying, new prototypes are breaking the sound barrier, and engineers believe they've cracked the problems that grounded the Concorde. So what's actually happening right now, and could we really see supersonic passenger jets return? Why supersonic travel disappeared, the end of an era. The Concorde was a marvel. It flew at Mach 2, twice the speed of sound, cruising at around 60,000 feet. It connected New York and London in just under 3.5 hours. But despite its engineering brilliance, the Concorde had serious flaws that eventually sealed its fate. First, it was incredibly expensive to operate. Fuel consumption was astronomical compared to conventional jets, and ticket prices reflected that. Only the wealthiest travelers could afford a seat, which meant the market was always limited. Then there was noise. The sonic boom created by breaking the sound barrier was so disruptive that most countries banned supersonic flight over land. This restriction meant the Concorde could only fly profitable routes over oceans, severely limiting its commercial potential. Safety concerns also played a role. The tragic crash in Paris in 2000 damaged public confidence, even though the aircraft had an otherwise strong safety record. Add in rising maintenance costs for aging airframes and engines, and the economics just didn't work anymore. By 2003, both British Airways and Air France retired their fleets. The world lost its only supersonic passenger service, and for 2 decades, nothing replaced it. But that silence is ending now, and several projects are actively working to bring supersonic travel back, learning from the mistakes that grounded the Concorde. The X-59 Quest, NASA's solution to the sonic boom problem. One of the biggest obstacles to supersonic flight has always been the sonic boom. When an aircraft breaks the sound barrier, it creates a shock wave that hits the ground as a loud, disruptive bang. This is why overland supersonic flight was banned in most places. NASA, working with Lockheed Martin, believes they've found a solution with the X-59 Quest. The X-59 recently completed its first flight, marking a major milestone in what NASA calls the Quiet Supersonic Initiative. Instead of a loud boom, the X-59 is designed to produce a much softer sound, more like a gentle thump. The difference comes from the aircraft's unique shape. Its long, narrow fuselage and specially designed nose help spread out the shock waves, preventing them from merging into a single loud boom. The goal is to reduce the noise to something comparable to a car door closing in the distance. If this works, it could change everything. The X-59 is expected to fly at around Mach 1.4, which translates to roughly 925 miles per hour. That's significantly faster than any commercial airliner today, though not quite as fast as the Concorde. It cruises at about 55,000 feet, high enough to help with both noise reduction and fuel efficiency. NASA isn't planning to turn the X-59 into a passenger jet. Instead, it's a research aircraft. The data gathered from its flights will be used to demonstrate to regulators that quiet supersonic flight is possible. NASA plans to fly the X-59 over several communities in the United States and collect feedback on the noise levels people experience on the ground. If the results are positive, it could lead to changes in regulations that currently prohibit supersonic flight over land. This would open up entirely new route possibilities for future supersonic airliners, making the business case far more attractive than it was for the Concorde. The X-59 represents a fundamental shift in how the industry approaches the sonic boom problem. and its success could pave the way for a new generation of fast jets. Boom, XB-1 and Overture. Private industry takes flight. While NASA focuses on research, private companies are building actual passenger jets. Boom Supersonic, based in Colorado, is one of the most ambitious players in this new race. Their approach started with the XB-1, a smaller demonstrator aircraft designed to test key technologies. The XB-1 recently achieved a historic milestone by successfully flying supersonic, becoming the first privately developed jet to break the sound barrier. This wasn't just a publicity stunt. The XB-1 serves as a critical testbed for the aerodynamics, materials, and systems that will eventually go into Boom's full-scale airliner, the Overture. The Overture is where things get really interesting. It's designed to carry between 60 and 80 passengers, making it much larger than the XB-1, but still smaller than most conventional airliners. The cruising speed is expected to be around Mach 1.7, which is slower than the Concorde, but still fast enough to cut transatlantic flight times roughly in half. Boom claims the Overture will be optimized for efficiency, using modern materials and engine technology that simply weren't available when the Concorde was designed. The company has already secured orders and commitments from several airlines, including United Airlines and Japan Airlines, signaling real commercial interest. Boom is targeting entry into service by the end of the decade, though that timeline depends on completing test flights, securing regulatory approval, and finalizing production. The Overture is also being designed with sustainability in mind, at least compared to past supersonic jets. Boom is exploring the use of sustainable aviation fuel, which could help reduce the carbon footprint of supersonic travel. But challenges remain. Building a brand new supersonic airliner from scratch is enormously expensive and technically complex. Boom has faced skepticism from industry analysts who question whether the company can deliver on its promises within the proposed timeline and budget. Still, the fact that the XB-1 has already flown supersonic gives Boom credibility that other startups lack. If the Overture succeeds, it could be the first new supersonic passenger jet in over 50 years. China's C949, the new global competitor. Supersonic development isn't limited to the United States. China has quietly entered the race with the C949, a supersonic airliner concept being developed by COMAC, the same state-owned company behind China's conventional passenger jets. Details about the C949 are still somewhat limited, but early reports suggest it's designed to be a serious competitor on the global stage. One of the most interesting claims is that the C949 aims to be significantly quieter than previous supersonic jets. Some reports even compare the noise level at certain stages to that of a hairdryer, which would be a dramatic improvement over the Concorde's thunderous roar. If true, this would address one of the main barriers to commercial supersonic flight. The C949 is also expected to have greater range than earlier supersonic airliners, potentially opening up routes that were never feasible for the Concorde. China's investment in this project reflects the country's broader ambitions in aviation. COMAC has been working for years to compete with Boeing and Airbus in the conventional airliner market, and adding a supersonic jet to the lineup would be a major statement. The Chinese government has the resources to fund long-term aerospace projects that might not make immediate financial sense, which gives COMAC a different kind of flexibility compared to private companies. However, the C949 is still in the early stages, no prototype has flown yet, and many technical details remain unconfirmed. There's also the question of international certification. Even if the C949 flies successfully in China, getting approval to operate in Europe, the United States, and other major markets will require meeting strict safety and environmental standards. Still, the fact that China is pursuing supersonic travel shows that this isn't just a niche interest. Multiple countries and companies see potential in bringing back fast passenger jets, and competition could drive innovation faster than any single project alone. Revolutionary engine technology, hybrid systems, and adaptive design. Engines are the heart of any aircraft, and supersonic jets have always demanded extraordinary performance from their power plants. The Concorde used turbojet engines with afterburners, which were powerful but incredibly thirsty. Modern supersonic projects are taking a completely different approach, leveraging advances in engine technology that didn't exist in the 1970s. One of the most promising developments is the concept of adaptive engines. These engines can adjust their internal airflow and combustion characteristics depending on flight conditions, optimizing performance for both subsonic and supersonic speeds. This flexibility allows the engine to be more efficient during takeoff, climb, cruise, and landing, reducing overall fuel burn. Some companies are also exploring hybrid electric systems. While a fully electric supersonic jet isn't realistic with current battery technology, hybrid systems could use electric motors to assist during certain phases of flight, such as takeoff, which is one of the most fuel-intensive and noisy parts. This could reduce emissions and noise around airports, addressing two major concerns that plague the Concorde. Another key innovation is the use of advanced materials in engine construction. High-temperature composites and ceramic matrix composites allow engines to run hotter and more efficiently without degrading. Hotter combustion temperatures generally mean better fuel efficiency, and these materials make it possible to push performance further than was safe or practical in older designs. Noise reduction is also a major focus. Modern engine designs incorporate features like chevrons on the exhaust nozzles, which help break up the jet stream and reduce the noise signature during takeoff and landing. These changes won't eliminate noise entirely, but they can bring it down to levels that are more acceptable to regulators and communities near airports. The combination of adaptive design, hybrid systems, and advanced materials represents a fundamental leap forward in propulsion technology. If these engines perform as expected, they could make supersonic travel far more viable than it was during the Concorde era, both economically and environmentally. Materials, science, and aerodynamics, building better supersonic jets. Speed comes with unique challenges. At supersonic velocities, air friction heats the aircraft's skin to temperatures that would melt conventional aluminum. The Concorde's fuselage actually expanded by several inches during flight due to thermal stress. Modern supersonic projects are tackling this problem with advanced composite materials that are lighter, stronger, and more heat-resistant than the metals used decades ago. Carbon fiber composites are already common in conventional airliners, but supersonic jets require even more specialized materials. Engineers are using titanium alloys, advanced aluminum-lithium compounds, and in some cases, ceramic composites that can withstand extreme temperatures without adding excessive weight. Weight is critical because every extra pound reduces range and increases fuel consumption. Aerodynamics have also improved dramatically. Computational fluid dynamics, or CFD, allows engineers to simulate airflow over an aircraft with incredible precision before a single piece of metal is cut. Wind tunnel testing, which was the primary tool in the Concorde era, is now complemented by computer models that can explore thousands of design variations in a fraction of the time. This has led to more efficient wing shapes, fuselage contours, and inlet designs that reduce drag and improve fuel economy. One area of focus is the aircraft's nose. The long, pointed nose of supersonic jets isn't just for looks. It's carefully shaped to manage the shock waves that form at high speeds. Small changes in the nose profile can have a big impact on how those shock waves behave, which in turn affects both drag and sonic boom intensity. Another consideration is takeoff and landing performance. Supersonic jets need to operate from conventional airports, which means they can't be too loud or require excessively long runways. Modern designs use advanced flap systems and variable geometry features to improve low-speed handling without compromising high-speed efficiency. The combination of better materials and smarter aerodynamics means that today's supersonic jets can be faster, quieter, more efficient, and safer than anything that came before. These aren't just incremental improvements. They represent a complete rethinking of what a supersonic airliner can be. The regulatory battle, changing laws for overland supersonic flight. Even the best-designed supersonic jet won't matter if it's not allowed to fly where people want to go. For decades, regulations in the United States and many other countries have prohibited civil aircraft from flying faster than the speed of sound over land. This rule effectively killed the Concorde's commercial potential by limiting it to oceanic routes. Changing these regulations is one of the biggest hurdles facing the return of supersonic travel. The good news is that regulators are starting to take the issue seriously. The Federal Aviation Administration in the United States has been working with NASA and other stakeholders to develop new standards based on noise levels rather than a blanket ban on supersonic flight. The idea is that if an aircraft can demonstrate that its sonic boom is quiet enough to be acceptable, it should be allowed to fly over land. This is where the X-59 becomes critical. NASA's plan is to fly the X-59 over several communities and gather data on how people react to the reduced sonic boom. If the noise is deemed acceptable, it could provide the evidence needed to convince regulators to change the rules. Similar discussions are happening in other countries. The European Union, for example, has its own noise regulations, and any supersonic aircraft hoping to operate in European airspace will need to meet those standards. International cooperation will be essential because airlines want aircraft that can fly routes across multiple countries and continents. Certification is another challenge. Any new aircraft design must go through a rigorous process to prove it's safe, reliable, and meets all regulatory requirements. For supersonic jets, this process is even more complex because many of the systems and flight characteristics are outside the experience base of existing regulations. Regulators and manufacturers will need to work closely together to develop new certification standards that are both safe and practical. The regulatory landscape is slowly shifting, but it's a slow process. Changes to international aviation law don't happen overnight, and there are legitimate concerns about noise, safety, and environmental impact that need to be addressed. Still, the momentum is building, and for the first time in decades, there's a realistic path forward for overland supersonic flight. Environmental challenges, fuel burn, emissions, and sustainability. Speed has never been free, and supersonic jets pay a particularly high price in fuel consumption. The Concorde burned roughly 5 times as much fuel per passenger as a conventional 747, and that kind of inefficiency is simply unacceptable in today's climate-conscious world. Modern supersonic projects know they have to do better, but the physics of high-speed flight make this a difficult problem to solve. At supersonic speeds, drag increases dramatically, and overcoming that drag requires a lot of thrust, which means burning a lot of fuel. While new engine designs and better aerodynamics help, supersonic jets will always consume more fuel per mile than subsonic aircraft. The question is whether the gap can be narrowed enough to make supersonic travel environmentally defensible. One approach is the use of sustainable aviation fuel, or SAF. SAF is produced from renewable sources like plant oils, waste materials, and even captured carbon dioxide. It can be used in existing jet engines with little or no modification, and it produces significantly lower life cycle carbon emissions compared to conventional jet fuel. Boom and other companies are planning to use SAF in their supersonic jets, which could help offset some of the environmental impact. Another factor is altitude. Supersonic jets fly much higher than conventional airliners, typically above 50,000 feet. At these altitudes, the environmental impact of emissions is different. Water vapor and other combustion products can affect the stratosphere in ways that are still being studied. Some researchers worry that a large fleet of supersonic jets could have unintended effects on the ozone layer or contribute to climate change in ways that aren't fully understood yet. Then, there's the question of fleet size. If only a few dozen supersonic jets are flying at any given time, the environmental impact might be manageable. But if hundreds of them are crisscrossing the globe, the cumulative effect could be significant. Balancing the demand for speed with the need for sustainability will be a central challenge for the industry. It's not clear yet whether supersonic travel can ever be truly green, but companies are at least trying to address the issue rather than ignoring it. How well they succeed will determine whether supersonic flight is seen as a luxury for the rich or a legitimate advancement in transportation. The economics of speed, who will actually fly these jets. Supersonic travel has always been expensive, and that's unlikely to change anytime soon. The Concorde charged premium prices, and even then, it struggled to make money. Modern supersonic projects are betting they can do better, but the economics are still challenging. Building and certifying a new aircraft costs billions of dollars, and supersonic jets are more complex and expensive to operate than conventional planes. Ticket prices will have to reflect that. Boom has suggested that overture fares could be comparable to current business class prices, but even that would put supersonic travel out of reach for most passengers. The target market is business travelers, celebrities, and wealthy individuals who value time more than money. For someone who needs to make a quick trip for an important meeting or event, cutting travel time in half could be worth a significant premium. Airlines are interested, but cautiously. United and Japan Airlines have placed orders for the Overture, but these are relatively small commitments. Airlines want to see proof that the aircraft works, that it can be operated profitably, and that there's enough demand to fill the seats. The pandemic showed how vulnerable the aviation industry is to sudden disruptions, and airlines aren't eager to take huge financial risks on unproven technology. Route selection will also be critical. Supersonic jets are most advantageous on long routes where the time savings are substantial. A 3-hour transatlantic flight is compelling, but a 1-hour supersonic hop between nearby cities probably isn't worth the extra cost. This means supersonic travel will likely be limited to a handful of high-demand routes, at least initially. If the economics work on those routes, the network could gradually expand. There's also the question of whether supersonic travel will ever become mainstream. Some analysts believe it will remain a niche market, a premium option for those who can afford it. Others think that as technology improves and costs come down, supersonic travel could eventually become more accessible. History suggests that new transportation technologies often start as luxuries and become commonplace over time, but that process can take decades. Timeline and expectations. When will we actually see these aircraft? So when will you actually be able to book a supersonic flight? The answer depends on which project you're talking about, but the next few years will be critical. NASA's X-59 is already flying, and testing will continue through the mid-2020s. The goal is to gather enough data to present to regulators by around 2027 or 2028. If the results are positive, regulatory changes could follow within a few years, opening the door for commercial supersonic flight over land. Boom's Overture is targeting entry into service by the end of the decade, with test flights expected to begin in the next few years. That timeline is ambitious, and delays are common in aircraft development, but Boom has already demonstrated supersonic flight with the XB-1, which gives them a solid foundation. If everything goes according to plan, the first commercial Overture flights could happen around 2029 or 2030. China's C-949 is further behind. No prototype has flown yet, and development timelines are less clear. It's possible we could see the C-949 flying by the early 2030s, but much depends on how quickly COMAC can move through the disappearances, testing, and certification process. Other companies and projects are also in the mix. Though most are in earlier stages, some are focusing on smaller supersonic business jets rather than full-size airliners, which could reach the market sooner. It's worth remembering that aviation development is slow and expensive. Even with modern technology, bringing a new aircraft from concept to commercial service takes at least a decade, often longer. There will be setbacks, delays, and challenges along the way. But the progress over the last few years has been real and significant. For the first time since the Concorde retired, there are multiple credible efforts to bring back supersonic passenger travel, backed by serious money and real engineering. The dream isn't dead. In fact, it's closer to reality than it's been in over 20 years. The roar of supersonic engines might return to our skies sooner than most people think. The technology is advancing, the prototypes are flying, and the industry is betting that enough people want to fly faster to make it all worthwhile. Whether that bet pays off remains to be seen, but one thing is certain: the age of slow flight might not last forever.